Effective tracking of all your model experimentation is super critical for any machine learning project. And in this video, we will see how we can apply different MLflow tracking feature and how we can store all the model hyperparameter matrices and different type of tags within my local backend store, and how we can store all these model artifacts within my local artifact store. Okay, so now let's start. So here first we would be importing all the packages, and the main important thing is this one. So we need to import MLflow package, and then we need to import MLflow.sklearn, and then the client one. So these are the important statements which we need to import as a part of our model experimentation, because this will allow us to log all the model artifacts or whatever we would be logging as a part of our experimentation process. It would be visible to us. Okay, so let's run this. Then we'll check simply the version just for tracking purpose. Now it's done. So the next step, you need to simply download the Kaggle recruitment dataset from Kaggle site. So just go and download the data and store it somewhere within your local repository. Okay, and next we will be simply loading this dataset. We'll explore it quickly. Check the target outcome. So target outcome in this case is status. So which is nothing but the student has been placed in the campus recruitment drive or not. So that's the target outcome. Okay. And next we need to start the MLflow UI, right? Because here all the model artifacts or whatever we would be logging as a part of your experimentation activity, it would be visible within this MLflow UI. So you need to just click on this and just go and browse this URL. So it would be visible in 127.0.0.1 and the port is 5000. Okay, so that's the UI you will see. And right now you will not find any experimentation because we haven't started any model experimentation, right? So we'll simply pause it. So we'll simply interrupt this kernel and we'll proceed to the next set of activities. So in next set of activities, we would be initializing MLflow, right? Because right now it's empty, and now we'll initialize the experiment. So the first set, we need to provide the experiment name. So here I'm providing the experiment name as Campus Recruitment Experiment version 1. And next we will be configuring the artifact store. So where you would like to store all the model artifacts. So I'm telling that please store it within the local repository, and within local repository, create MLflow -run. So if you look the current repository, we don't have anything, but once we'll run it, it will create this repository and will store all the model artifacts. Okay, and next we are setting the tracking URL. So what would be my tracking server? So here I am just telling my tracking server would be this, because here my MLflow UI would be running, but it could be anything, and depending upon where you have installed the MLflow, and it can be within your AWS cloud or Azure or Google. So wherever you need to install the MLflow, and accordingly you can set the tracking URI. But here I am just using it for local. And next we need to initialize the MLflow client, because with the help of this MLflow client we can create the experiments and we can perform the other activities required for my model experimentation process. Okay, so that's the first step. Once my client gets created, we need to create experiment ID, right? So with the help of client.createExperiment, we would be able to create one experiment for my model run. And here I am passing the experiment name as this one. Okay. And in next step, I am just configuring the artifact stored. So artifact stored in this case is my local repository. So that's what I have configured it here. Once we'll run this statement, it will create one experiment ID, And using this experiment ID, we would be able to log all the information which we would be configuring within this notebook. It would be visible within this MLflow UI. We'll show this shortly. So I will just run this statement, right? And whenever you will run the same shell for the second time, it will go to accept. It will go to accept loop, right? Because we don't need to create the experiment ID again, and it will use the existing experiment ID, and will log all those information within the same experiment name, right? So that's the purpose of adding try and accept section. Okay. Once that is done, I will prepare my data for modeling purpose, right? So these are the normal set of activities which we normally perform, right? So defining all the training features, right? Encoding your target column, and just exclude the features which you don't need to use for your model training activities. So that's what I have done it here, right? So I will not go in detail because this is about the model experimentation process, but these are the pretty much standard process which we normally follow for all the machine learning activities, right? So here I'm simply splitting my data into training and test, and here we are simply encoding the categorical features, right? So we'll simply run it. Once that is done, in next section we will be defining my model experimentation function, right? Now we'll first run these cells and then we'll explain what it means. So simply run it, and as a part of next step we will be training one logistic regression model, and using this model experimentation function, it will log all the relevant artifacts within MLflow UI, right? So we'll see it. So we'll simply run it. So now you can see that my validation AOC is 0.89, and this is confusion matrix, ROC AOC curve. And now we'll see what sort of information it has logged within MLflow UI. So we'll simply refresh it, and now you can see that we have campus recruitment underscore experiment underscore v1 experiment name, and that's what we had configured initially, right? So that's my experiment name, and here you can find out the artifact location. So whatever artifact repository you would have stored or configured, it would be visible within MLflow UI. So right now my artifact location is MLflow-run. Okay, so that's what we had configured here. Okay, so that is fine. And next, once you'll click on this experiment link, just click it. So this is for my logistic regression through which we had performed as a part of this activity. So it has logged all the relevant artifacts, so parameters, matrices, model artifacts, everything. So we'll simply click on this, and now you can see different things it has logged, right? So we'll explain one by one. First, you can see the notes. So it has added a brief introduction about what you are trying to achieve as a part of this experiment. So here I have simply written, this is an experiment for exploring different machine learning models for campus recruitment datasets. So that's what it has logged. And next we can see that we have different set of parameters which logistic regression model has used for training. So that's what it has logged. And next we have different matrices which we have logged as a part of this experimentation. So you can see that we have validation AOC, we have training accuracy, we have different matrices relevant for my model training. So it has been logged. And next we have some set of tags, right? So using these tags, we can configure different release versions, release candidate, what type of estimator we would be using. So everything has been logged under tag section. And next we have different model artifacts. So here you can see that I have logged my confusion matrix, this ROC AOC curve I have logged, and this is about the requirements. So right, so this is about my entire virtual environment which we had used in this model experimentation process, right? So using this you can find out what package version we would have used at the time of model experimentation, and using this requirement.txt file, you would be able to replicate the entire Python virtual environment. Okay. And this is for the training side of things, right? So you can see that we have different artifacts for validation. We have different artifacts for training. We have also logged Python virtual environment. And this is about the model artifact, right? So you can see that it has all the model artifact detail here, right? In the form of this, and we have also pickle file. So using this, you would be able to load and perform any activities against your trained model, right? So, and here the Conda YAML version, right? So we have different artifacts which are very useful from tracking and monitoring purpose. And now we'll see how my code has enabled it to log these many things within my MLflow UI. Okay. So that's the first statement we have within the model experimentation, right? So MLflow.startRun. So that will allow you to start the activities, whatever you have written within this loop. Okay. And here I will be passing the experiment ID. So experiment ID from where we will get from here. So at the time of creating experiment, we will get the experiment ID. Okay. And that's what we are passing it here. And now we can pass the run name. What would be the run name for my experimentation? So here we have passed the run name from my calling application, and I'm passing the run name as logistic regression model. And you can see this detail from your main site, right? So here is the run name. So that would be visible here. So for different model, you'll have different run name, and using this, you'll be able to track what sort of model training you have done and for against which type of model. Okay. So that's what we had done here. And using this, you'll be able to find out all the run ID, right? So using this run ID, we'll be creating different sort of nodes, right? So that's what we had seen here. So once you'll click here, you'll find this node, right? And that's what we have logged using this statement. MLflow client and MLflow client set tag, and we need to pass the run ID for my run. And in column, we need to pass mlflow.node.content, and whatever message you would like to print here within your experiment, just mention it. Okay. So that's what I'm doing it here. And next, we would be using the auto logging functionality within MLflow, mainly around the sklearn functionality, right? So for different packages, we have different auto logging functionality. So we can use LightGBM or XGBoost or Tensorflow. So we have different auto logging functionality which will log some default parameters and default matrices available against that package. So it will log everything, right? So, and that's what we had seen. It has logged all the parameters by default. So these are the auto logging functionality. So whatever parameters your machine learning model would be using, it will log everything here. And that's a part of your auto logging functionality. Okay. And also it will log some of the default matrices. So you'll see that all these training matrices are coming as a part of auto logging functionality, right? So we haven't specified any additional code for logging these matrices. It's automatically provided by my auto logging functionality. And the third is model artifact. The model artifact which we had seen here, these are also provided as a part of auto logging functionality. So that's why I have used MLflow sklearn.autolog functionality to log some of the default behavior of my model. Okay. Once that is done, we need to define the custom tags. That's what I have defined here. And we can set these tags with the help of this statement, MLflow.set tags, and we'll pass this as a parameter. And that's what you'll see it here, tags, right? So application, we have passed the application, release candidate, and release version. And that's what you can see it here, right? And these two values are from the auto logging functionality. Okay. So in this way, we can club both auto logging and custom logging functionality, right? So whatever you need to add as a part of tag so that you can distinguish one run from the another run, you can define it appropriately. Okay. Next, we will be logging the model Python version environment with the help of log artifact, right? So I will be taking requirement.txt from a local environment, and we'll be simply adding it within my model artifact, and that's what you can see it here, requirement.txt. Once you will perform this statement, it will log it like this. Okay. And then we are performing simple training. We'll initialize your classifier, and then it will be performing training operation against your training data set. And here we will be simply performing a model evaluation, and we are calculating ROC AOC value against my validation data. So once we'll have that value available, we'll simply log this value within MLflow with the help of MLflow log metrics, right? And here we will be passing dictionary as validation AOC equal to my ROC AOC value, which we had calculated here. So that you can see it as a part of ROC AOC validation ROC matrices, right? So here you can see like this. Okay, that's we have logged with the help of this statement. And next we will be plotting simple confusion matrix. We will be saving that as a PNG file, and then we will be logging that as an artifact, MLflow.log artifact, and that's what you can see it here. Validation confusion matrix, which we had logged from here. So in this way, you can create multiple plots, and with the help of MLflow log artifact, you will be able to log all those information within MLflow, right? And next we will be simply creating a ROC AOC curve, and we'll be logging it with the help of MLflow log artifact, and that's what you can see it here. Okay, so in this manner, this model experimentation function has logged all the required information for my experimentation process, and these are the aspects we would like to track as a part of my model activity, right? And these information are stored within your local repository, and for artifact the location is this. Okay, so we have already done it for logistic regression. Now we'll perform a couple of more activities, and now we'll train a decision tree classifier, and we'll see what happens. So initially the validation AOC score for my logistic regression model was 0.89, and now we have trained decision tree classifier, and the validation AOC was 0.85, right? And here we are simply passing classifier name as decision tree classifier. Whatever parameter you need to pass, you can just define it. Model name is DT, run name is decision tree model, and we will be passing all these values as a part of model experimentation function. Okay, so that's what we are expecting as a part of this function. So we have, now we'll refresh it, and now we'll see what it has right now. Okay, we'll refresh it, we'll click it, and now you can see that we have another row for decision tree. Okay, you can click it, and using this you'll be able to find all these informations, right? So whatever you have logged it. Now we'll run one more model, random forest. This time it will be random forest. We'll just run it, and the validation AOC score for this was 0.88, right? And now you can see we have one entry for random forest. Okay, we'll run one more, this time gradient boosting, and this time the validation AOC score for my gradient boosting was 0.89, and now we'll see it. We'll refresh it, and now you can see that we have one more entry for gradient boosting. So this way we have trained 4 different type of models, and you would be able to track your validation AOC score. So you can see the validation AOC score for all those 4 models were captured here. Right? And it has also different type of matrices which it has captured as a part of your experimentation process, right? And at last we'll train one more model. So this time we will be training LightGBM model, and here I am defining it separately because sklearn version of LightGBM does not have auto logging functionality, and that's the reason I have defined this separately. And here we'll try to log all the information manually, and in this way we would be able to combine the auto logging functionality and custom logging functionality in a single model experimentation process. Okay, so all the activities would remain same. So these are exactly similar to what we had discussed, right? The only difference we had with respect to how we log the parameters, right? So here you can see that I am logging parameters with the help of MLflow.log params, and in parameter we will be passing the entire dictionary, right? So that's the first difference. These are exactly similar to what we had seen, and next we would be logging the model artifacts, right? So with the help of MLflow.sklearn.log model, and in parameters we will be passing the trained LightGBM classifier, right? And that's the name of where you would like to store this model artifact, right? The other thing would remain same, and next we will be passing the validation. We will be calculating validation AOC, and then we will be storing the validation. It would be exactly similar to what we had discussed previously. Okay, and next it will calculate the feature importance for my LightGBM, and that's what we had done here. Plot importance is an inbuilt function within my LightGBM package, and you can see it from here. From LightGBM we are simply importing plot importance and plot metrics, these 2 functions, and we will be using this within my model experimentation function for LightGBM, right? So here I'm simply calculating plot importance. We'll be plotting it, and we'll be saving it, and we are logging this as an artifact, right? And next we'll be calculating the plot metrics, okay, for training and validation, and we'll be logging this as an artifact. The next set of activities would exactly similar to what we had seen: confusion metrics and ROC curve. So for LightGBM we had created 4 different plots, and we have added all those plots as a part of model artifacts. Okay, so now we'll simply run it. Okay, so it has plotted feature importance. So this is my metrics, log metrics, which we had seen here. Plot metrics, that's the plot for my training and validation, confusion metrics, and ROC curve. So that's it, and now we'll see what it has logged here. Okay, click here, and now you can see that we have for LightGBM. So in this manner we have logged model training activities for 4 different type of models. Click here, and now you can see that we have logged all the parameters which we had passed. We have metrics as validation AOC, and that's the reason you are not seeing all the default matrices which are available as a part of auto logging feature, right? Tags which we had defined, all the custom tags and all the model artifacts, you can see it here, right? And this model which we had used as a part of this statement, MLflow.sklearn log model, and that's it visible here, right? And you can see all the plots which we had calculated and plotted as a part of our training activity, and this is the Python virtual environment. So in this manner you would be able to track different runs again a given experiment. So here my experiment name is this, and under this experiment we had performed 5 different runs, right? And now you can see that we have different validation AOC score for all those 5 models, and depending upon requirement you can pick the best model based on your validation AOC performance. So you can sort this validation AOC and you can pick the best model. So from this, as per my different runs, we can pick LightGBM model, right? And then further we can optimize the different parameters for my LightGBM so that we can build a better model for my campus recruitment dataset, and then we can deploy the best model in production. Now we'll perform LightGBM hyperparameter tuning. So now what I have done, I have taken entire code from this notebook and I have put it in a separate notebook so that we can perform hyperparameter tuning for LightGBM model. Okay, and in this notebook all these steps would remain same except for some additional changes which I will discuss. So here I have defined the experiment name as version v2, right? So against this experiment I will add all the details required to perform the hyperparameter tuning. Okay, so that's the first change. The second change which I have done in this notebook, I have taken the entire LightGBM code from this notebook and I have put it in a separate function, right? So I have taken entire piece of code here and I have captured this within different function, model training tracking function. Okay, so that's the second change. The third change which I have done for hyperparameter tuning is to add some additional functionalities so that we can perform a Bayesian optimization based on Optima package, right? So for that I have defined one objective function, and in that objective function I have defined parameters, and for parameters the ranges I have defined, right? So here I have defining learning rate, column sample by tree, and subsample parameter, and for these parameters I have defined the range, right? So for learning rate I have defined that the value should range from 0.01 to 0.1, right? So that's the variation we would be exploring for learning rate. And similarly for column sample by tree, my optimization function will explore different value between 0.4 and 1, and similarly for subsample it will explore value between 0.4 and 1. That's the only changes I have done in objective function, and from this objective function we will be calling this model function where we had defined all the LightGBM model training and all the logging activities. Okay, that's what we have done here, and this function will return ROC AOC value which we are capturing it here, and the objective function will return this value, right? And we'll try to maximize the value of AOC, right? Because we need to find the different hyperparameters for best AOC score, right? And that's what my Optima package will allow us to do, right? So here we are defining simply a study, and in that statement I am creating a study and we are telling to maximize the outcome. So what we would be optimizing? We would be optimizing based on the value returned by my objective function. So here we are simply giving study.optimize, and within optimize we are passing the value of objective, and we are telling to perform 40 different trials. So that means 40 different variation of different hyperparameters. So that's what this statement is telling. And after this optimization function, it will record the best value of my trial, right? So out of 40 trials, whatever value will get from my best trial, it would be captured against this variable, and using this we will be printing the best hyperparameter from this statement, right? So that's the purpose of adding these additional statements which will allow us to perform a hyperparameter tuning for the variable which we had defined within the objective function. Okay, so now we'll simply execute it and we'll see what comes out of this. So we'll simply run it, we'll define the objective, and now we'll start the hyperparameter optimization. So it has started, running different runs for based on different value. Okay, so we'll wait for some time and you'll be able to find all these experimental results within my MLflow UI. And within MLflow UI, you'll be able to find all the variations of different hyperparameters. And you can also see the value, your validation AOC score, and you can compare it against different hyperparameters. Okay, so now we'll go to this site, MLflow UI, and we'll refresh it so that now it will have different versions. So now you can see that I have version 2 and the name of my experiment is V2. And here you can see that I have different runs for my hyperparameter tuning. So now it's complete. Now you will be able to see all the variations of your hyperparameters. And now we'll try to find out the best validation AOC score. So now we'll see the best validation AOC is 921, which is an improvement, right? Because if we'll track the initial validation AOC score for your LightGBM model, it was 0.917, and after hyperparameter tuning, my validation score has been increased to 0.921. Right, so that's the purpose of performing the hyperparameter tuning. And once you'll click on this link, you'll find all the different value it has picked for column sample by tree and learning rate and subsample ratio. Okay, and you can find the validation AOC score is 0.921, and you can find all the different model artifacts, right? It has logged. Okay, so that's the purpose of this activity, and you can also compare all the validations runs. So just click here and click on compare. Okay, and here you'll be able to see, click on parallel plots. So I will remove metrics, I will remove objective, and now you can track the interaction of different parameters on your validation AOC score, right? So this is a very handy tool for monitoring how your validation AOC score varies based on different set of parameters and how it interacts with each other. Okay, so that's a very useful way of monitoring your parameters. Okay, and here you can see the validation AOC score for different runs. Okay, so you can clearly see that it varies. Okay, and you can also compare the scatter plot, right? So here I can see the learning rate, and on the y-axis you can plot the validation AOC score. Okay, and then you can see how it varies depending upon different type of learning rate. Okay, so it max at this point. Okay, so this is the maximum validation AOC score which we have received at 0.049. Okay, now we have seen how it is easy to create different experiments for different runs, and how we can track and visualize different hyperparameters we have used during our experimentation process, and how we can compare different type of validation performance metrics so that we can understand how my model is behaving and how it interacts with different model hyperparameters, right? So initially we started doing experimentation around 5 different type of models, and then we picked the best model from this experimentation, and then in second step we have done hyperparameter optimization against my best model, and using that hyperparameter optimization we picked the best model based on the validation AOC score, right? And now we can deploy the best model into the production, right? So now we'll see how we can achieve that objective in this Jupyter notebook. Okay, so in last step what we will do, we will pick the best model, right? And how we can pick the best model? So for that we need to go to the model experiment number 2. Just click on the link where we have received the best validation AOC score. So that's the link we will be clicking. So just click on this link, go to model artifacts. So here I have the model artifacts. So just click on this link and you'll find the run ID, this location, the full path, right? And that's what we need to define it here. So we need to define exact path. So just copy this, okay, and then paste it here. Okay, so that's it. And with the help of MLflow sklearn load model, we would be loading the best model, which we have found out from my hyperparameter optimization tab. Okay, and then we'll take the best model, we'll create a prediction score against my validation data, and we'll simply print it. So let's do it now. So now you can see the results. So now we have seen how we can apply MLflow model tracking in our project and how we can use different functionality provided by MLflow to track and monitor our model experiments. So I hope you'll find this useful. Thanks for watching it.